Welcome back to another edition of Myth Badger videos. Let's take the universal joint we built in a prior video to examine it to understand a little bit more about the mechanics behind how it works. Now before we do that, I do want to point out one small correction. I made a mistake in the video for building this, and I forgot a piece on either side. So what I forgot here is a bolt. Now this particular bolt is meant to help hold the angle gusset here to the L gusset in the bracket so that way the angle gusset doesn't actually swing too far away. We want to make sure that those are kind of connected there. And there's going to be one on either side. Now we want to make sure they're not too tight because we do want this piece to be able to slide around within there. Now that also brings up one other piece. Right now, with the way it's built, some of these pieces do loosen up a little bit. It's partially due to the pieces that we're using. But you'll notice, for instance, the angle gusset is actually rotating here, but not on that side. And that just could be that the piece is just a little too loose. I didn't tighten it enough. But I can do something in order to prevent that angle gusset from turning at all, and that would be to add another bolt. And if I look on the inside here, I could add another bolt for this angle gusset right through this hole here in order to provide two anchor points for that angle gusset so that these don't move. It's just this bracket that moves. So that is an improvement we can make on this to help reduce some of that movement a little further. Unfortunately, there is going to be some loosening due to the parts that we have. So I just wanted to cover that real quick before we continue. Now, going a little further, let's go ahead and take a look at what we see here. So I'm going to have you make a prediction here. We have the back end and the front end. Which one do you feel is going to be the input? So make a prediction on that. If you're thinking that, well, I can see the handle sticking up here in the back, so the back end of this gear is the input, well, you would be correct. So our output is actually going to be up here in front, and we can see that as we rotate here. So knowing the input and output, now the question becomes, what is the gear ratio in this particular system? And for that, we're going to actually take a look at the gear itself that connects everything together, this hinge here. And based on what you see, do you think this is a 1-to-1 or not a 1-to-1 ratio? Well, some of you might take a look at this and say, well, both ends are the same size, so that means it's probably 1-to-1 for a ratio. And actually, that would be correct. To examine this a little more closely, there's two things we can look at. One of them is to look at the pins where these are connected to actually see how these two prongs here rotate. You could also pay attention to the set screws that are in either the universal joint or the locking collar. But if you pay attention to the pins, I'm going to rotate this once. I'm going to rotate that particular pin so it goes all the way around once. And I'm pay attention to the prongs on the output end of this. So here's one rotation. Now, if you're looking closely, you might say, well, that prong there looked like it only went around once. So that's confirmation of the 1-to-1 ratio that we're seeing here. Okay, so if this is a 1-to-1 ratio, would the speed and torque be increased, decreased, or constant? Well, as we've seen before, a 1-to-1 ratio means that the speed and torque are going to stay constant through the whole system. In reality, the big value of a universal joint is its ability to change the angle at which it operates, not necessarily the speed and torque. So this is not a gear that you would probably use if you need to be able to vary either of those values. However, if we do want something that has an angular range or can be adjusted to fit in several different positions, this would be a useful gear to consider. Now, what we are referring to here is actually the range at which this output can be adjusted. So I could move this up, or I can move it down to give myself more angular range to work with. Now, right now, as I said, you're seeing the gusset is moving a little bit, and I've mentioned some ways that you can avoid that. But if that was locked down, I could probably more easily control where it's positioned. So the angular range on here is not very far, just due to this design that we've used. But if, in reality, with the universal joint, this particular universal joint, our angular range is roughly 90 degrees up to about 270, but we don't go exactly to 90 or 270. So it's slightly above 90, and slightly lower than 270 degrees. So that's quite a range of motion that this gear can be used at. And it'll operate in both. So I can sit here, and even while it's lowering, I can have it turning. So it's a useful little joint. Now let's take a look at flow of power on this. So based on what you've seen so far, do you think it's possible that I could make the input turn by rotating the output? Let's give it a shot here and see if your prediction is true. If you predicted that the flow of power is reversible, as you can see, that is correct. Now that we understand flow of power, what about direction of travel? Can I actually turn this in the opposite direction? And yes, I can. I can turn this in both directions and it'll work. So we do have a reversible direction of travel as well. The last little detail we're going to look at is the direction that the input and output shafts turn. And for that, let's position so you can see the set screw here. And I'm going to be turning this, and we can pay attention to the set screws here, or more easily, pay attention to the set screws on the joint itself and see if they turn in the same or opposite directions. As you can see, they are turning in the same direction, which means, kind of like the chain drive, the universal joint, the input and output shafts will turn in the same direction. So in review, our input in our device is over here on the back side with our output on the front. When we look at the universal joint itself, we see they have the same sizes on both halves. So this is a 1-to-1 gear ratio. And because it's a 1-to-1 gear ratio, speed and torque are constant in this system. The big value is the ability to adjust the angular range, which the full range is slightly above 90 degrees all the way up to slightly below 270 degrees, even though my angular range on this device is much smaller. When looking at this device, we find that it does have a reversible flow of power and the direction of travel is reversible. And lastly, the input and output shafts do rotate the same direction when turning. So thank you for watching, and hit that subscribe button if you want to keep up with all future tutorials here at Myth Badger Videos.